I will talk about the cloud in a minute. But first, I was listening to Joel's talk. I was sad not to be able to listen properly to Susie's because APIs are something that's near and dear to my heart. But as so often happens when you're at a conference, one talk sort of bleeds into another to some extent. So I wanted to briefly talk about the importance of diversity because of precisely what Joel was saying. So software developers are writing the future, yeah? Who are the software developer community? If it is mostly straight white men, then mostly straight white men will be solving the problems that straight white men have, and that's not good enough. In the UK next year, we will be celebrating 100 years of women having votes. Well, votes aren't the only way that rules get made. It was fantastic to see the elections just this week of so many more women in legislative positions in the US, and so many more people of color, and openly transgender legislators. This is fantastic, but it has to happen in software as well. Because if we're writing the rules, they need to be rules that work for everyone. OK, small rant over. Thank you. So I'm not generally talking about that today. I'm talking about cloud. Now, just to introduce myself, so I am Jon Skeet, and I'm a C# developer at Google. There aren't very many of us that do that, but basically my job is to make the Google Cloud Platform awesome for C# developers. You may also know me from Stack Overflow, and I've built a few things like Node-time, my date and time API. And the good thing about working for Google on C# for the cloud platform is I'm not actually doing all the really, really difficult stuff down at building Cloud Spanner and awesome kind of very computer science heavy things. Those people are fantastic. They are much deeper thinkers than I am. I just get to use it and build on it and expose it to other people. But that means that I face the same kind of problems and options that you will face if you're trying to use our cloud platform, which means I have some experience of your joys and pains. Now, the good thing is I get to ask internally, when I run into a problem, I can get an answer more easily than some of you would be able to. But it does mean I see some of the pain that people face. And likewise, on Stack Overflow, I get an idea of things that are causing problems. So that's really where I'm coming from today, and trying to give an idea of what options are available in cloud now, and why, if you haven't already moved to cloud, now is the time to do so. Or at least now is the time to start. Now, possibly disappointing to some of my colleagues, if any of them are listening, is I'm not a salesperson. I am hopeless at selling anything. So I won't be saying Google Cloud Platform is the best because. I'm sure it is. I just can't tell you those reasons, OK? So go to the Google booth, ask my colleagues. They will give you loads of reasons. I'm talking more generally about cloud. Because I want to help you build stuff. Okay, that's generally the theme of my life. So Node-time is not an application. It is something that will help you build applications. I've written a book, and that isn't an application. It's something that helps you build. I answer questions on Stack Overflow because I want you to be successful at building awesome stuff. Maybe I could build awesome stuff myself, but I'd rather sort of enable lots of other people to do so as well. And the cloud does likewise. So I want to start off telling you a story. It's 1996, and I'm in my second year of university. The most important thing that happened during that year was that I met Holly Webb, who I later married. So by far, if I think of the great impact of university on me, is my wife, basically. However, other cool things happened as well. I started building Yoda. Yoda was my first internet-connected desktop, and it was a monster. So I had previously at home had a 386, and I brought the motherboard and CPU and didn't have a case for it. And a friend of mine was selling the case and power supply of, I think it was an Amstrad 1640 or something kind of obscure. And I got a hard disk from somewhere, and I sort of bolted the whole thing together. And I actually had, so I had the power supply, and the motherboard didn't fit into the case of this Amstrad 1640. So I had a pad of paper, and then the motherboard sitting on top of that. And obviously, it couldn't go straight on the power supply because it would short everything. But then I ended up with a problem, which was that if I put the ribbon connector straight from the motherboard to the disk, it went quite near the memory. And that caused kernel panics. So I had a chopstick. I had a chopstick-enabled computer. So this is what it looked like. And there's the chopstick. You can see holding the ribbon connector up. And as I say, that was an integral part of the computer that was completely vital. And you can see there's duct tape holding the whole thing together. This was not the world's most lean and mean computer. But it worked. It was ugly as anything, but it worked. And it was plugged directly into my college room's Ethernet. So that was my first internet-enabled machine, and that ran my website. And then in my third year, I had another machine, which was actually in a full case. This was great. This was a real computer. It had one problem, though, which was when my website, primarily at that point, my Stephen King website, which had a sort of encyclopedia bit with lots of links to things within it. And when Alta Vista decided to index that, which it did roughly once an hour, that hit the site quite a lot. And so I could hear the hard disk clicking. So it really was deploy to click rather than click to deploy. Now, I was in my room at college for about half the year. And the other half of the year, my college rented out my room. And so I left my computer under the desk, and I put a little label on it saying, this is running my website. This is my live website. If you could bear to leave this on, that's great. On the other hand, no one's going to die if you just turn it off. There's the power switch. So it sort of brought a slightly different ring. When people say best effort computing, this was really kind of OK effort computing. But it was still a bit better than Yoda. And then a friend of mine started an ISP, as you do. And he said, would you like us to host your website? And I was like, yes, this is great. And this was still this was now remote. I never saw the machine. But I did SSH into it and edit the HTML directly. No source control whatsoever. If I tried to build something and the build failed, then that bit of the site was down for that period of time. But it was a bit better. Now, I never saw the machine, but I suspect there was one machine at Araxis that was running my website, probably with another machine to fail over to. But there was a machine that I suspect had been lovingly set up. Fast forward to today, and I'm mostly happy. I've taken my hands further and further away, and this is the point of the story, is I've gradually got further away from the machines running my websites. I now have effectively 3 websites. There's csharpindepth.com, nodatime.org, and jonskeet.uk. And nodatime.org is an ASP.NET Core site, and the other 2 are still ASP.NET web forms. But they're running in the cloud. I can push to GitHub to deploy, and it's mostly OK. But I'm not there all the way. If I were all the way there now, I probably wouldn't have bothered telling this story. The point is that I've taken little steps, and there are further little steps I can take. However, hopefully, none of you really care that much about the history of my websites beyond how it maps to you. So I don't know what any of you do. Well, a few of you down there, my friends from Stack Overflow. But most of you, I suspect, have a little server in the corner somewhere. A little server that you are frightened to touch. A little server that you are frightened might suddenly do a Windows update and take down your intranet for a few hours. I can see people sort of nodding away occasionally. And basically, if you're in that situation, or even if you're a bit further along than that, or a lot further along, my point of the talk today is do the next step. So let's think about a few different scenarios. So Maybe you are in a greenfield environment. Maybe you are about to start a project. When you get back from Web Summit, you've got a product requirements document ready to go. You are going to start coding on Monday. That's an amazing situation to be in, okay? I suspect every engineer here knows the joy of starting from a blank canvas. Okay, there's a Stephen Sondheim musical, Sunday in the Park with George, that I'm going to be talking about at other conferences, how that relates to software. But it starts saying, white, a blank page or canvas. The challenge, bring order to the whole through design, composition, balance, and harmony, and probably a few other things. I haven't memorized it properly yet. But isn't that just a great idea for software? You start with a blank canvas, and you can do anything. Okay, there are no rules. You can decide the future. So maybe you expect me to suddenly say, right, so you must write a 12-factor app with microservices on XYZ and be prescriptive. Well, maybe that's the right thing for you, maybe it's not. There are options. But I would say start by thinking about the options that are available via cloud. So if you want to just upload your source code to the cloud, that's fine, use platform as a service. If you want to upload little bits of code to the cloud, use functions as a service. I hate the term serverless. Okay? Do you think anyone would say that a taxi service is carless transport? No, it's sort of using a car without really caring about what that car is. Well, yeah, you're using a server to run a little bit of code. You still care that there is a server, otherwise that code isn't going to run. So I'll talk about functions as a service instead of serverless computing. However, there are loads of options, and it partly depends on how hands-on you want to be. So if you have your source code and you just want to let the cloud run it, you've got platform as a service, function as a service, you might want to be a little bit more hands-on and say, OK, I will design these services, and I want them to be deployed in this pattern with this sort of scaling profile. And obviously, it should be dynamic, because if you can predict before you start writing a service what the traffic is going to be, then, well, we have plenty of jobs for you at Google if you have that kind of predictive power. So maybe in that case, Kubernetes is the solution for you. But you need to make those decisions. Most of us aren't in that situation. Let's look at the other end of the spectrum. So legacy. I couldn't write this slide without thinking of Hamilton. Legacy, legacy. What is a legacy? It's planting seeds in a garden you never get to see. We don't really think of legacy code like that, do we? It's more like planting weeds in a garden that we don't have to maintain. But it's there. It is that PC in a corner. And anyone who talks about cloud and only sells you on the greenfield side is missing probably the majority of our applications, because we've all got legacy. And the great news is that, again, the cloud has matured to embrace that. So you've got that Windows server in the corner that you don't really like. Fine, take a VM image, upload that VM image with lift and shift services. They're fairly common these days, and it's running in the cloud. OK, it's still potentially a horrible application written in COBOL, or I don't know what it is. It's not going to magically transform that code to be better. But it will at least mean that you don't need to worry about having a power cut in your office. And of course, you've got everything in between those extremes. And the great thing is, these days, hybrid cloud, whether that's between multiple clouds, maybe it's between Azure, AWS, and GCP, because there's one API that works particularly well on Azure. There are many, many APIs that work particularly well on Google Cloud, and there's one API you just have to use on AWS. Sorry, I've got to be partisan occasionally. You can do all of that. If you've got some services that you've got to keep on-premise for whatever reason, I don't need to know those reasons. That's fine. You can have some of them locally and some of them in the cloud. My point is, it's an option. So my challenge for you that I really want you to take away is to go and change one thing. Think now, maybe send yourself an email to your work account, not your personal account, to your work account, so that on Monday, you will start automating or moving to the cloud or just taking one step. It may not be making it in the cloud so much as more cloud ready, but accepting that something cloudy is in your future and taking that first step towards it. I'm going to do that this weekend. I'm going to take one of those ASP.NET web form applications already running in the cloud, but I'll change it into ASP.NET Core if I can find the time. And that way, it will be more portable. I'll be able to run it on more clouds more easily. OK, so that's my pledge to you, is to try to do what I'm asking you to do, because I hate hypocrisy. So send yourself an email over lunch saying what you want to do. And of course, I'm here from Google, so yes, we have you covered in all those cases. You want to use Kubernetes? We've got you covered with Container Engine. Platform as a service, we've got you covered with App Engine. Function as a service, you've got Google Cloud Functions, and so many more options. The one thing you can't say about cloud is that I don't have enough options. There isn't that thing that I need. Chances are, whatever your need is, you will find some way of doing it. Finally, go do something awesome. I have recently started watching a program called Halt and Catch Fire. Any of you been watching that? Yeah, I have heard it is the least appreciated best thing. Go watch it. It's about computing in the 80s. And this salesman says, the computer isn't the thing. It's the thing that lets you get to the thing. Cloud is more than that. Cloud isn't the thing. Cloud isn't the thing that lets you get to the thing. Cloud is the thing that lets you get to the thing that lets you get to the thing. Cloud lets you get to your code running, scaling however you want it to, interacting with however many 100 APIs, doing awesome things. That's not the thing. The thing is the impact you have on other people's lives. You could have the best code in the world, and if no one uses it, it doesn't matter. The thing is the change you make in other people's lives. You could be curing cancer. You could be connecting people with each other. You could just be providing a game that makes people happy on the bus. All of these are the things. You will write the awesome code that lets people get to the thing. Cloud isn't going to write that code for you. You have to go and be awesome. But cloud is the thing that lets you be awesome. Thank you very much.